Welcome everyone to the Ecological Continuity Trust's 9th webinar. We're very lucky to have Rob Mars, who's an emeritus professor at the University of Liverpool, speaking to us today. And he's going to talk about the future of some of his long-term experimental plots. And afterwards we'll have a discussion about those plots and hear other people's views about what their future might be and how we might use them in the future. So thank you very much, Rob. It's over to you.
Okay, yeah. Hi, well, welcome everybody. This is a bit odd talking to my computer screen, but there you go. These are the two experiments that I'm going to talk about mainly. One is at Hordron Edge in Derbyshire, and the other one is just round the hill at Bamford Edge. But I thought, given the context of what we're talking about, I'd actually start off with if you like, the experiments that I have known. And these are the ones I can remember, and I'm not sure I've got all of them, but starting in Mull, going right the way around down into Devon. And if we go on, these are ones that are more than 3 years old. These ones are more than 10 years old, and these are the ones that have lasted the longest. These ones are still current, sort of, with the exception of these ones have died last year. I'm still working at Moorhouse, and these are the two that are the subject of the talk today. And they were originally part of a series of 7 experiments, the bracken control and regeneration experiments. And there were originally 7 of them, starting at I can remember how to do this, laser pointer. You can see that the two in Scotland at Surup over here. Can you see that with a pointer?
Yes.
Okay, there, the 2 in Surup. There was 2 in the Peak District, the ones we're going to talk about today. There was 3 at Cannock, just north of Birmingham, and there was 1 over in the Carnethau. In 2004, we started another one in the Peaks, but essentially they were all part of the same story. They all had 6 common main plot treatments. There was randomised blocks. There was site-specific restoration treatments, which I'll come on to later. And we collected data annually from 1993 to 2006. And other sites, and as I say, 1 site, Hordron, is still going, and 2 sites have been resampled along the way. The extra experiment, I'll come back to later, also, again, is still going. And that's basically it and expanded. You can see that some of them were acid grasslands, some of them were meant to be heathlands, and they all had various different complicated experimental designs. Those are essentially the experiments, and basically there's a whole host of stuff already been published on this. There's a whole load of papers published on how bracken responds, the fronds, rhizomes, fronds again, and 1 on biodiversity. We did a whole load of work on seed banks, how the seed banks were affected by treatment. We did some work on the wider landscape. We had a database. We had a database that didn't work in the long term, but it did help us get our data in good order. We contributed to policy. This was done partly with Robin Pakeman, who was involved in this, and we also have done some work testing ecological theory. We tested basically alternative stable states, and again, I'll come back to that later. So that's, if you like, the history. Right, where we are now is, I'll start off by going through the phase 1 of the Hordron experiment. And there's actually been 3 phases here. The first phase lasted for essentially 10 years. Now, the experiment was set up over about a hectare of land, and it was a split plot experimental design with 3 blocks. The 6 main bracken control treatments were the same as applied to all the other experiments. There were 2 levels of stock fencing, grazing or no grazing, that's sheep, and 3 levels of Calluna seeding as a sub-treatment. So it's a fairly complicated experiment. There are 3 replicate blocks, and within each of these there are 6 bracken control treatments. Untreated, cut once per year, cut twice per year, azulam once in 1993, azulam in 1993, and then cut once in 94, and then cut in 93, and azulam in 94. So these were, at the time, potential bracken control treatments for use in the wider countryside. And of course, they were all randomised. They're not in that order. Within each of these, there was a grazing and a non-grazing treatment. And again, these were randomised and these were randomised. And then within that, there were 3 seeding treatments, untreated, brash, Calluna as brash, and Calluna as litter. Essentially, there were 108 subplots to assess each year. So it's a substantial job to work on. And I'm just going to go through what I think is the best bit of work that came out of this, and this was the test of alternative states and alternative stable states. So before I do that, I'll just go through principal response curves, because they're actually quite a useful technique for assessing the effects of treatment effects in properly designed experiments. Okay, well, for the first part, it's multivariate, so it takes all species into account. But you need a gradient, and here it's time. And if you want to work on time, you need long-term data. And we had 10 years of data from 7 replicated experiments. Okay, I mean, essentially, what you're doing is you've got a control, which is that line there. That's the untreated line. That's your control, and your treatments are the green line. And what you're measuring is a deviation from the control, and you use randomization tests in order to test for significance. And here is an example of something that really hasn't had a treatment that's not had an effect. It's essentially the state is highly resistant, and you've got no deviation from the control. This is an example where you've got a very moderate resistance to start with, and you've got this massive increase and effect at the start, but then as it goes on through time, it goes back down again. This is what you really want, is you've got low resistance at the start and high resilience at the new state, and you've created something different from the control. So that's what you're really looking for. And we had 2 things. We had one-off treatments, the azulam and the azulam with cutting treatments. And when this happened, you would create an alternative stable state if this result was the outcome. With the cutting treatments, they're continuous, you're applying them all the time. You're not going to have an alternative stable state because you don't know whether it's these annual cuts that's keeping it in this particular position. So that was our thinking. And quite clearly, you have a species list down the outside, which tells you which species are involved in this deviation. Well, in our first analysis, we showed that the grassland and the heathland sites were wholly different. So we analysed them separately. Sorry. Well, here's the heathlands. And you can see here that after sort of 5 years, all of the treatments were significantly different. So they've all overcome the initial resistance. However, through time, the azulam treated plots regressed, and by this point here, they were no longer significantly different from the untreated. Whereas the cut plots actually went up and continued and created an alternative stable state. Sorry, an alternative state. The grasslands, the azulam treatments were much quicker to become significantly different, and it took to here for them all to be significantly different. And at the end of the 10 years, they were all significantly different from the untreated plots. So they have created an alternative stable state for the azulam plots and an alternative state for the cut plots. And that's in summary. This is phase 1. The PRCs allowed rigorous tests of AS and ASS theory, statistically defensible. You need long-term data from replicated experiments where any treatment effect is compared to control. Robin Picknich used these as well. Heathlands, you had evidence of an alternative state, but needed a continuously applied treatment. Acid grasslands, you got both an alternative stable state in the one-off treatments and an alternative state where the cutting was applied. Now, the problem with this is it's over the time period measured. So that after 10 years, we decided to move on. So if you like, we shifted the thinking of the experiment into a different phase. So in 2004, we allowed some treatments to continue, the untreated quite clearly as the control. We kept the cutting treatments going, but as the three azulam treatments were, if you like, failing, we resprayed it with azulam, and then after that, we continued with an annual spot spray of azulam to every emergent fronds without respite. And I'm using this this English quite specifically because that's what the person who designed this technique used. So essentially, we've kept the same names there, but since 2004, the treatments have been the same and have been azulam with this annual spot spray of fronds. There's been one paper published on that, which you're welcome to read. And although this is on soil properties, actually there's a lot of the information on bracken and species hidden in the supplementary materials. But on this slide here, you can see that the bracken frond length, the azulam treatments are down to virtually nothing. The cutting treatments have still got some bracken. The frond densities, the azulam treatments are down to nothing. Litter cover, it's almost gone. So we're into a grass heath mixture. And I won't spend a lot of time on that. You can read the paper if you're interested. And again, we've got temporal change over about a 20-year period. And you can see that for these 4 treatments, the effects have been pretty good. The bracken has almost gone in both grazed and ungrazed plots. Now, we were thrown a bit of a curveball in 2012 when azulam was supposedly banned. It hasn't been, well, it has been banned, but ever since then there has been a derogation for its use in Britain, which is now actually, after 8 years, has become almost sensible. But at that point, I realised that azulam might have a problem, so I decided to stop spraying it. So now phase 3 for this experiment, the bracken is now being allowed to recover. And in this phase, that's where the results are at the moment. I've collected a load of data and I haven't analysed it. What I can tell you is that sheep grazing is very important. And I'm not going to say any more than that. So I'm waiting on the next sampling before I do any more. Now, so I'll move on to the Bamford experiment. Now, this one was set up in 2004, and it was specifically set up to test the old theory of cutting thrice per year as opposed to twice per year. So we had the untreated plots, we had cutting twice and thrice per year. And I also wanted to test the old chestnut of a bruiser using bruising, and I did that twice or thrice per year. And we also included the azulam plus spot spraying thereafter. So there were 6 treatments: untreated, cut twice and thrice, bruising twice and thrice, and azulam with spot spraying thereafter. Now, I actually managed to get this into the journal. My squirty index, number of squirts per 400 metres squared, and you can see that I started in 2009, and you can see that the number of fronds being treated reduced to virtually 0. This is a map of the bracken fronds in the plots, and you can see that these are the 3 good treatments: azulam, cut twice, and cut thrice. Those 3 treatments were very successful in clearing the bracken almost completely from the plots. There's just some bracken around the edge. Now, the other 3 treatments, the bruising and the untreated, that's just basically bracken everywhere. The bruising was wholly ineffective, just didn't work at all. And I'm sorry about that, but that's what I found. Absolutely useless. So again, in 2012, all treatments are stopped and bracken's allowed to recover. So I've been sitting measuring the bracken coming back. And again, I was hoping that that might be very close to finishing. And again, phase 3 results, wait and see. But here's 2, remember these 2 golden oldies, the ones at Surup. Well, I went back, and this is new data. I've just analysed that this summer with a master's student. And I fitted GAM mixed models to these data, and you can see that this is the untreated, the 2 different sites, the Surup 1 and Surup 2. This is Surup 2. Surup 1 is the Surup 2 is the red one. The Surup 1 is the blue one, and you can see that even on the same site, you get massively different treatment effects. Massively different responses in the untreated plots. What I've done is I've replotted the untreated plots on each graph in black, and you can see the treatment effects. The Surup 2, you've got a massive dip and then a recovery in both the cutting treatments. In the Surup 1, it's a much more slower and more measured impact, and you're still having an effect after 25 years. The spray treatments, you get an initial knockdown and then recovery. So what I've done is effectively, let's see if I can get this to work. What I've done is I've gone from there to there, and effectively said that is the window of success, the effect window for the treatment of cut once per year at this particular site. And we've worked that out for a whole host of factors, and you can see that some of them appear relatively good. There is an effect relative to doing nothing for a considerable period. And I'm still in the process of writing this up, so it's not actually completed. So that's the end for the moment. And thanks to these guys, DEFRA, who paid for the initial 14 years of this study, the Heather Trust have funded it at odd times, and the Leverhulme Trust are funding it at the moment. And there's a whole host of people involved in this. Mike Leduc, who set the experiments up as a postdoc, Robin Pinkman was a supervisor, Emma Taylor, a PhD student, Joshua Waldy, a postdoc, Hugh McAllister, our ID man, who's fantastic, and Mallory and Jeremy Archdale for allowing us to work on their sites. So really, the next phase, and what I intended to do, was actually to shut the experiments down. And the reason is, I think they've run their course. And at Hordron, I want to do a final sample, and particularly do a fairly intensive destructive sampling of the rhizomes. And that, I think, will, I mean, we've sampled the rhizomes before, but we've done it fairly low key. And I think I'd like to do quite a lot of sampling, and that would actually knacker any future responses. At Bamford, I think the final sampling in 2021 is probably okay, because that one is relatively easy to monitor regress using satellite imagery, drone technology, or whatever. I've had drones flying over the site, so I've got some imagery already. And certainly for the Bamford site, you can pick stuff up quite well on Google Earth. So that's where I am at the moment. I mean, really, we have used these experiments for other people. I mean, there's a guy from Manchester, Martin Sharma, came and did all sorts of soil analyses of the Hordron experiment, and he was going to do a lot of molecular identification of stuff in the soil. I haven't seen the data for that yet. I don't know. He's gone back to Holland now. He's got a job at Leiden, so I've no idea whether that will ever, you know, come good or not. But you know, that's where we are at the moment. So that's it. So thank you.